This is the second set of work solutions for Mechanical Science Sheet 10. An area 10 kilometers square has an annual rainfall of 300 millimeters. The rainwater gathers into a lake from which it is piped down through a height of 100 meters by a hydroelectric power generating system. Ignoring the fact that some of the water will evaporate, how much power could be generated by the system? So we can start off with 10,000 by 10,000. This gives us the area of the rainfall, and then we multiply it by the height of the rainfall to get a 3D volume of rainfall. So that's 0.3 meters because we have 300 millimeters of rainfall. So this is the total rainfall for the year, but we need to figure out how much rainfall we have on average per second. So we divide this by 365 days and also by 24 hours per day, and then 3,600 seconds that we would get in an hour. So this would be around 0.95 meters cubed, and 1 cubic meter is equal to 1 ton of weight. So this kind of tells us that we're close to a ton here of weight, but it's not quite. So we can sort of see it's 95% of a ton, which is 950 kilograms that we get. Okay, so we've got 950 kilograms. So now, how much potential energy could we get from that? So potential energy, we tend to do mgh, and we've got our mass of 950 and our acceleration due to gravity, let's say it's 10, and our height is 100 meters, so we put 100 in here, and if we multiply those together we should get, I'm just going to get my calculator to make sure I get the numbers correct. So that's 950 times 10 to the power of 3. A spring of stiffness 1,500 newtons per meter is stretched between 2 points 2 meters apart. If the tension in the spring is 200 newtons, what was the unstretched length of the spring? And what was the energy stored in the spring when stretched between 2 points? So first of all, we can say F is equal to Kx from Hooke's law. Okay, and we can say X is equal to F over K. And in this case, our F is 200 newtons and our K is 1,500. With that, we can say that our extension is 0.13 meters. And we can say that our original length L is equal to our extended length, which is 2 meters, minus our extension. So that's going to be 1.87 meters. For the energy stored in the spring, we can use the equation half kx squared, and if we plug those values in, we get half 1,500 and our extension was 0.13, and we square that and we should end up with 12.675 joules. A train starts from rest and accelerates uniformly at 1.2 meters per second. What is the speed of the train after 30 seconds and how far has it traveled? So we've done these sort of questions before, but just as a reminder, we have V is equal to U plus AT, and we can say u is equal to 0 and a is equal to 1.2 and t is equal to 30, and we can plug that in and we end up with 36 meters per second. Okay. And then for the distance travelled, we say v squared minus u squared is equal to 2as. And then we can say s is equal to v squared minus u squared divided by 2a. And if we plug those in, we end up with 36 squared minus 0 divided by 2 multiplied by 1.2, and that's going to be equal to 540 meters.